This is Cody. This is Alan's pre-cal class. And this is our project.
Hey, I'm Rishi, and I'm part of the group.
So, these numbers are the weight of each balloon in grams, and these are the pullbacks of the slingshot, ranging from 5 to 7 feet, and then the time is the time it takes for the balloon to travel from the slingshot till the target. Now we're going to talk about initial velocity.
This is the initial velocity formula. This is the velocity, and this is height at sub-zero since we're landing at 0 feet, starting from 0 feet, landing at 0 feet. And you also see that height over here, but we're looking for the velocity here in the formula.
This is the weight of the balloon in grams. This is the pullback, and this is the time. So we have to plug that time into this equation.
H is going to be 0 since we land at 0 feet. So you plug in time, and our time is t. So since h is 0, timesing it by t is still going to get us 0. So we go 0 equals negative 16, which is gravity, parentheses, the time, which is 15, or 5.15 squared, plus velocity, times time again, and this is basically plus 0 since our height is 0. Square the 515 and you times it by the negative 16. So if you put that in the calculator, 5.15 squared equals 26.52, and then you times that by negative 16, and your answer should be negative 424.36. And write the rest of the formula, which is velocity plus velocity times 515. And you don't even have to write 0 because it's nothing. So, to get velocity by itself, which is this again, you're going to add 424.36 to bring it on this side. So you get 424.36 equals velocity times 515. To get velocity by itself, you're going to divide it by 515. Oh gosh. 515. If you plug that into your calculator, 424.36 divided by 515, you should get velocity equals 82.4, and that's your initial velocity. Now that we found that initial velocity is 82.4, we're going to use this and the distance formula. And if you remember, the time that we used was 5:15. Okay, with shooting something, you're going to have to decide what angle you want to do from the ground. Okay, you have a bunch of different angles. You have a 90-degree angle, you have a 45, which is half, 45, which is half of a 90-degree angle, and then you can shoot below or above 45, but you will get the most distance shooting with a 45-degree angle. The angle we're choosing to do is 45 degrees. The distance formula you're going to use is d, which is distance, equals velocity, cosine, theta, t, and t stands for time, and theta is the angle you wish to pick. And then you plug them in. Distance formula, d equals velocity, cosine, theta, which is your mysterious angle, and t for your time. Now you're going to plug your information into the distance formula. So you're going to have d equals your velocity, which is 82.4, cosine, theta, which is the angle you choose. So you picked 45, so you're going to plug in 45, and then your time, which is 5:15. In your calculator, you're going to plug in 82.4 cosine 45, parentheses, 5.15 equals, after you plug it in your calculator, you're going to get D equals 300.06. That's how it's done. This balloon is 162 grams.
Angle we chose is 45.
And the pullback 7 feet.
Degree angle.
During our first pullback, we did everything correctly, but it didn't go as far as we thought it would.
That far.
Alright, during our second attempt, we did everything right, but we scooted up a lot more, but we had too much of a pullback and caused it to go too much.
This time we got the calculations right and we hit the target.
Yeah, I put that on, like, yeah.
I wonder if she saw it. Did you tell her that you guys aren't cool?
It's still up. Oh shit.
I didn't do that.
Okay, who did that?
Tatiana did
Brad.
that. Tatiana.
You did it! Who was it? Who's laughing now?
Don't make me laugh.
What's up?
You should, Tatiana. Just do it, be a good intro, Tatiana. Now it is. It'll be a good intro.
Let's go! Yeah! For those of you that want to know what we're all about, it's like this, y'all. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, 100% reason to remember the name. He doesn't need his name up in lights, he just wants to be heard, whether it's the beat of the mic. He feels so unlike everybody else, alone, in spite of the fact that some people still think that they know, but no, he knows the code. It's not about the salary, it's all about reality and making some noise.